Hi there. We're going to be finding the nth term of sequences in this video, of quadratic sequences to be more specific. Now, for your GCSEs, you only need to know how to find the nth term of linear sequences and quadratic sequences, and a few other nth terms that are more trivial, like, for example, the nth term of square numbers and cube numbers. But by far, quadratic sequences are the hardest kind of sequences that you need to find nth terms of. So, and basically the definition of quadratic sequences, or the form that they're in, is this over here. So un equals an squared plus bn plus c. Now, a, b, and c are constant, so they'll just be numbers. Like, for example, it could be 5n squared plus 4n minus 2. They can be negatives too. And un is basically just a way of writing the nth term. So the nth term of the sequence is that. And then, for example, if we can put in u5, for example, that'll be what is the value of the sequence at term 5, and then we just substitute in 5 into here. And then 5 squared will be 25 times 5 is 125 plus 20 minus 2. That'll be 143, for example. This is just an example of a quadratic sequence. And you can actually tell here that this is actually in the form of quadratics, because if you think about your quadratics in the rest of algebra, when you have x's, it's in the same form. So that's why they're called quadratic sequences. Now, for a second, I just want to show you why they differ from linear sequences. So a linear sequence is another kind of sequence that you need to know how to find the nth term of. And this is an example of a linear sequence. And you can see that it goes up in 4 every time. So we say it has a common difference of 4. And then the nth term for this would be 4n minus 1. So there's no n squared term in linear sequences. You can even think of it as being in the form bn plus c. So it just doesn't have this an bit in it, or this an squared bit. So yeah, that's a linear sequence. Now, quadratic sequence is something in this form, and we'll find the nth term of this sequence right after this. But for now, I just want you to pay attention that the difference between 2 and 9 is plus 7. The difference between 9 and 18 is 9. And then if we keep going, we get 11 and 13. So unlike a linear sequence, it's not a common difference. It's not a fixed amount. It's a different difference each time. But one thing to realize is what we can say now is we can find the difference between the differences. So the difference between 7 and 9 is 2. The difference between 9 and 11 is 2 again. And the difference between 11 and 13 is 2 as well. And you can see now that we've got a fixed difference. It's like the linear equation. And this is called either the difference between the differences. That's quite a long way of writing it. You can just call it the second difference. So the second difference is this. So, and this is actually something that all quadratic sequences hold. So all quadratic sequences have a fixed second difference, i.e. this number is always going to be the same. But this first difference isn't going to be the same. So now let's actually figure out how to find the nth term of this sequence. So the question might ask you to find the nth term of this sequence, right? And whenever you're looking to find the nth term of a sequence, you always want to keep probably at least 4 at the very least. But you want 5 terms of the sequence already. You don't want to, because it's easy to make mistakes when you only have 3 terms, for example. So it's always best to have 5 terms to find the first 5 terms and work from there. So we already know that this goes up like this. And then what we want to do is we want to find the second difference. And if I had to put it into steps, so step 1 would be to find second difference, and then find A. But how do we find A? Just bear in mind that when I talk about A, I mean when we have sequences in this form, obviously A is this value here. And the way we find A is by saying that A is equal to half the common difference. That's what it is. And well, in this case, we can tell that the common difference is 2. Not the common difference, sorry. The second difference. Because it doesn't have a common difference. Second difference. And we can tell that the second difference is 2. So if the second difference is 2, we could just substitute that into this equation, and we get 1. Or all we can do is, you don't need to learn an equation for it. You just need to know you find the second difference and half it. And then that's how you get A. Okay, so we have A. Well, that's good, but how do we find B and C? Okay, so this is where step 2 comes in. And it's to subtract an squared from original sequence. And okay, so let's do that. So we have UN, which is our original sequence, UN. And then we want to, so that's 2, 9, 18, 29, 42, like that. And remember, we're using the first 5 sequences, the first 5 terms, sorry. And then we want to subtract an squared. Well, we already know what A is. We know it's 1. So that's just 1n squared. And we know, because we know that this is just the square numbers, because the nth term of the square numbers is n squared, we can just list the first 5 square numbers, like so. And we want to subtract these. So we want to find un subtract n squared. So let's do that. So we get 2 minus 1, which is 1, 9 minus 4, which is 5, 18 minus 9, which is 9, 29 minus 16, which is 13, and 42 minus 25, which is 17, like so. And we can see here that we've got a new sequence. So let's find the nth term of this sequence. So we know that its common difference is 4. So this is just a linear sequence. So what we can do is we can just use the same rule that we normally use to find the nth term of sequences and of linear sequences. And we know it's 4n because it goes up in 4. And then to get from 4 to 1, we have to subtract 3. So we found the nth term of this sequence. And actually, and in fact, that would be step 3. So step 3, find nth term of new sequence, which we did here. We found it to be 4n plus 3. And then the final step will be to combine two nth terms to get final nth term. What this means is we need to add our an squared. So we already know what a is, right? And what actually happens is that these values here, this is our b, and this is our c. So what we can do is we can combine all of that together, and we get a to be 1. We know a is 1. We know b is 4. We know c is minus 3. So we could just substitute that into the formula up here. And then we get un equals n squared plus 4n minus 3. And that is our final nth term. Now, just a side note, you don't need to know why this happens. But if you're wondering why it turns out that this sequence here gives us our B's and C's, let's think about what we're doing here. So we have UN here, which is an squared plus bn plus c, right? And then we're taking off an squared. You don't really need to remember that there's an a because in our case it's 1. So we're taking off an squared. So if we take off an squared from here, we get an squared plus bn plus c minus an squared. So these two cancel out, and we just get bn plus c. And that obviously equals 4n minus 3. So these values are equal. And that's how it works. Okay, so let's look at a more complicated example. This one, the a will actually be greater than a will actually be greater than 1. So let's have a go. So let's find the nth term. Find nth term of 4, 15, 32, 55, 84, so on. Okay, and this is un. Or we could call this S with un being the actual nth term. That'll probably be smarter. So let's call this S for sequence. We're not really using it, but so you don't have to label your sequence. But yeah, un is more to do with when you're actually calculating the nth term. So let's remember our first step. So our first step is to find the second difference and then find a. So let's do that. So let's find our first difference. So in this case, we're adding 11, then 17, then 23, then 29. Okay, and now let's find our second difference. So it's plus 6 each time. Okay, now what you can do is to find a, we know a equals half of the second difference. So half of this, which will be 3. So we found a. Okay. So now our second step is to subtract an squared from the original sequence. So again, like we did last time, let's list the first 5 terms of our original sequence, like so. And then let's get an squared, which remember isn't n squared this time, because a is greater than 1. But what we can do is we can write, if we write an squared, on the side, what we could potentially do, or below it, let's just write n squared for now. So we know how to write that. It's just a square number. Now let's multiply it by 3. So it's just a little bit easier. Instead of doing multiple things at once, we could just say what's 1 times 3? Well, that's 3. What's 4 times 3? 12. 9 times 3, 27. 48, 75. So on. So now remember, we want to subtract an squared, which is this here, from this. So we get 4 minus 3, which is 1. So this is un minus 3n squared. 15 minus 12, which is 3. 32 minus 27, which is 5. And then keep checking each of these till you get the final sequence. Now we just calculate the nth term of this sequence. So it goes up in 2s. So a common difference is 2. So we get un minus 3n squared equals, well, it's 2n. And to get from 2 to 1, we just subtract 1, like so. And that's our third step there, which is to find the nth term of the new sequence. And now we just have to combine these together. So we know that a is 3. So un equals 3n squared. And then we know that this is b here. So we get 2n, this is c, and so on. Like so. Okay, so those are 2 examples on how to do. Okay, so try having a go at some of these exercises. And good luck.